If you can introduce something concrete to a child, it's easier for them to understand it. If they can see it, if they can touch it, if they can smell it, taste it, whatever, you're giving their senses a chance to experience that thing.
Good afternoon, everyone. This is Gretchen Rowe, and I am delighted to welcome you all to the Demi Learning Show today. We have a really special and kind of an interesting conversation to have because this may be something that you just really haven't thought about. But my dear friend and colleague Lisa brought this to my attention several months ago, and we really felt like we needed a deliberative conversation about it so that we could frame for you why this is so important. And although you will see it in the context of math today, I want you to understand that the principles we are going to talk about are omnipresent in much of our instruction, and we should be able to make the transition to recognize how important this is for so many kids. I'm going to let Lisa introduce herself, and then we'll get to the crux of the conversation. Lisa?
My name is Lisa Chimento. I am a support and placement specialist here at Demi Learning for almost the past 9 years now, full time. My husband and I homeschooled our 4 children for 25 years. They're all adults now and out of the house. And it's a pleasure every day to work with families. And this is an exciting conversation for me to have. I know it is for Gretchen as well, but actually, Gretchen, you're the one who brought the CRA model to my attention a couple of years ago when I had the opportunity and the pleasure of sitting in on one of your talks at a convention. And I hadn't heard of the CRA model before then. And then I did a little bit of digging in and researching on it. And then a few months back, a customer actually contacted me and said, I'm looking at Matthew C. and my child has dyslexia, and her dyslexia tutor said, we need to be using a math program that uses the CRA model. Does Matthew C. do so? And I was so excited to get that question. And it really just spurred in my mind, this is something that parents and teachers ought to know about. I think it's important. I think it can make an enormous difference in a child's ability to learn and really understand math.
I agree with you. And, I didn't realize because when we developed the AIM program, which is behind your head and behind mine here, when we developed those programs, we were very intentional to use the CRA strategies. But we realized it's also like throwing a rock in a pond. And Steve Demi was kind of prescient in the fact that the way in which he has structured Matthew C leans so heavily into this. Sometimes you get too close to the forest to see the individual trees. And I think we have reached the point where this is so much a part of our vernacular that it's important for us to take a step back and help parents understand why this makes such a huge difference for kids. So, Lisa, where shall we begin?
Okay, so we get a lot of calls every day. Kids either just starting out or they're along the way in their math instruction and they've been struggling, and parents aren't really sure what to do. And many programs will focus on procedures. This is how you solve this kind of a math problem. And kids who have the ability to memorize that kind of procedure quickly will latch onto that. I know I did when I was in school. I was all about the facts and the procedures and the rules and the formulas, but never really having understanding. And that showed up in things like word problems because I didn't know which operation to use, because I didn't really know why I was doing what I was doing or when I was supposed to employ a certain operation. If you told me which operation to use, boom, I could go there. But it really indicated that I didn't understand the math behind it. And it wasn't until I started using Matthew C with my own children that there were a lot of jaw-dropping moments of, oh my gosh, that's why we're doing this. That's why this works. And so to be able to see that and understand it now, when you go to work a word problem or just use math in life, now you know what to do because you have that underlying comprehension of those concepts instead of just, oh, this is what I do because somebody told me I need to do it this way. So this is what we wanted to do. We wanted to bring this idea about the CRA strategy. It's a threefold strategy for introducing, well, in this case, we're talking about math, but like you said earlier, it can be employed in many other areas. The first of the three steps is concrete. And I think most parents who have raised a child even for a couple of years know that if you can introduce something concrete to a child, it's easier for them to understand it. If they can see it, if they can touch it, if they can smell it, taste it, whatever, you're giving their senses a chance to experience that thing. And then the second step is called representational. So the concrete will involve in math, at least in math you see, we're dealing with manipulatives, physical manipulatives. Um, the R stands for representational, and now we're taking those physical items and we're presenting drawings, illustrations, some sort of digital picture of it. And then the A is abstract. And that's when we really get to the algorithm, the written equation or the mental math, all of that. So we want, but we want to make that progression. We don't just want to hit them with the equations on a page because that's procedural. It's necessary, but it's not going to build understanding. And we want to build understanding. So that's the introduction to the CRA model. If nobody's ever heard of it before, there you have it.
Well, and I also think it's important to note that you can be a student who captures the procedural, as you have said, but in the presence of stress, that will evaporate on you.
Oh, certainly.
And a lot of us who were only taught the procedural processes when we encounter math in the wild, as my kids say, when math shows up in the wild, we panic because we can't automatically archive or access that archive of procedural processes.
Correct.
So we may be speaking to many members of our audience here who are, you say you're not good at math. Maybe it's not that you're not good at math. It's just that there's a gap between your ability to recall the procedural process necessary for any particular function and the melding that is necessary to really fully understand that. For a lot of years, that was me. It wasn't until I found my way to math, you see, 7 years into my homeschool journey and 8 math programs 8 different math programs, because I was trying different things for different kids because I didn't understand what was missing, and parents may see some of the things that are missing today in this conversational process. So this actually has some science behind it, and I wonder, Lisa, if you could explain, because you're the one who brought Jerome Bruner's name to me. I think I had read his name all the way back when we were developing AIM, and then, of course, Teflon Brain, it just sort of disappeared out of my mind.
Jerome Bruner was a psychologist and an educational theorist, and the work and the research that he did in coming up with the CRA model really shifted the focus from behaviorism to how people actually learn and think and how they retain material information. And so this really helped him to better understand the mental processes that were involved in the way that humans learn. There is a woman named E.S. I don't know how to pronounce her last name.
I asked the internet to tell me, and it's Book.
Book. Okay, thank you. So she did a lot of research to support that the CRA, and also she brought in what she called the VRA, so that when concrete manipulatives weren't available, virtual manipulatives could serve as a replacement. Concrete is preferred if possible, but if not, then you could use the virtual manipulatives. Anyway, she supported that those frameworks are evidence-based practices for students. Especially notable is the way that they have made such an enormous difference for children with learning differences. different learning challenges. Um, and so we'll get more into that, but she, so let's see. So what we're going to talk about here, this science of the way that the brain learns best and the way that the brain processes information, understands that information, and then retains that information in such a way so that when a person needs to retrieve it, needs to recall it, then it's there for them. And that's what we found a lot of difficulty with. Now, on the whole, you mentioned something just a minute ago about the thing that happens when we lose or forget the procedures. And that happens often, especially if parents, if families are doing a typical school year and they take a summer off. We see this a lot when we get placement calls midsummer, towards the end of a summer, people are getting ready to place their kids for the new school year, and they put a math assessment in front of a child who hasn't done any math for weeks or months. Well, math is a language. It's You've said this before, it's the language of science, and like any language, if it's not being used regularly, it's easy to forget it. And so when kids have been heavily dependent on those procedures rather than understanding, and they haven't done it in a while, it's gone. And then you need somebody to remind you. I see this a lot when I see the way students work with fractions, and they're flipping fractions left and right and here and there because they've heard somewhere, they remember somewhere in the shadows of their memory that you're supposed to flip a fraction for some reason. They have no idea why or when or what it means, but they just take a chance and they flip one of the fractions and then do something with it. So that's what we want to try to help move away from, because those procedures are necessary to solve equations. But if you start with that, then that's as far as it's gone. We want to back this train up a bit and get going from a foundational point of view and get started from there.
When we say concrete here at Matthew C, this is what we're talking about. We're talking about manipulatives. So I have 2 plus 4 equals 6. And I can hold these, I can touch them, I can touch the backs of them, I can touch the nubs on the front. It gives me tactile input for what I'm actually holding. And the only reason that I make this digression is because last summer, when I did a presentation about math and anxiety, and I'm talking about the necessity of having a concrete representation, I had a mom who was so literal in the audience. She was seeing this as concrete as the stuff you pour for a foundation of a house. It is, in a way, because if you don't understand that 2 plus 4 equals 6, then moving on, because of its very nature, because math is sequential and cumulative, if you miss the basics, it's hard to build on that. So, Lisa, can you talk a little bit about the power of multisensory learning, what we have learned over the years here at Demi that tells us why it's different? What makes this different from, say, just numbers on a page?
Yeah, very, very different. And, I saw this from the moment we opened up our first level of Matthew C with the integer block. At that time, the kit was very different, but there was this poster we opened up, and there's Decimal Street on the poster. And what I realized was I had young children who were learning their numbers. We played with numbers, magnetic numbers on the refrigerator, and they could identify the numbers. But if you put the number 2 in the hundreds place, and then a number 2 in a tens place, and the number 2 in the ones place or the units place, you've got 222. It's the same numeral in 3 different places. But when they saw that decimal street and they saw the size of the blocks, the 100 blocks, the tens blocks, and the units blocks, all of a sudden you realize there's different values behind those numerals depending on what place they're falling in that number. And that was, to me, the most brilliant thing. I just couldn't get over it. And it just continues from there. So we are using, a lot of times we hear parents tell us, oh, my kids don't want to use the blocks because those are baby things. Well, I'll tell you what, they're not baby things, and I've had quite a few engineer dads come to our booth at a convention and ask for a demonstration, and then sit with their mouth hanging open when they see the way that these concepts are taught, because we're teaching algebraic concepts as early as the primer level, but all the way through into very formal algebra. And you're teaching some very highly abstract concepts, but when you present them concretely first, and the student can touch them and they can see them, and they are you're employing multiple senses, it makes such an enormous difference in their ability to understand. There's something else that we do wanna talk about, and one of the, folks that registered for the talk today asked a really great question about, can it make a difference for a child with dyslexia? And I'm gonna say it makes a difference for any child, but particularly for kids with learning challenges, and particularly for kids who tend to, historically struggle with that ability to recall or retrieve information when they need to. The ability to work with something and engaging multiple senses allows that information to be stored in a part of their brain where they can retrieve it when they need it. And that's what's making the difference here. It's not that dyslexic kids cannot retain information. Their difficulty is pulling it, calling upon it, is what I've often heard, or retrieving it when they need it. And this allows that to be placed in a place where they can retrieve it. So the brain is complex. I'm not a neurologist. I don't understand it all, but I know that it works. And so we want to, as often as possible, um, employ not only in the instruction towards the children so that they're receiving this um, receptively using multiple senses, but then they are also engaging with it expressively. And that's a big part that we want to bring in here, because once I started to really dig into the CRA model, I started to realize we've got something really good going on here, because the CRA model that we're already employing, and then you add to that the mastery approach that Matthew C. uses, and something that I think just doesn't get mentioned often enough, and that is Matthew C's unique sequence. And you put those 3 together, and you've got this trifecta for success. And so that's what we're gonna, get a little more into here today, but I'll let you, direct this.
No, that's okay. I appreciate the fact that you're saying that. And before we move on, I do want you had said to mention the quote that I gave you out of the book I was reading. I just finished a book called Open Ed. It's a fascinating book about changing our attitudes about education. And the reason this quote is relevant is because many of us who home educated our children came to the table with this idea. And that idea is that the system doesn't care about learning, it cares about processing. Now, I want you to sit with that for just a second, and then I'll unpack this for you. We have been taught as parents, because our education was taught this way, that it is an accumulation of effort. And there are things that we need to learn. And we measure that learning by taking a test. The challenge is, if that's the only measure of our learning, and I know I could probably ask anyone in our audience, or you, Lisa, have you ever taken a test and then you didn't recall what you did on the test a week later because you only retained the material for the length of that test? And what we're trying to do here with a CRA model is give our brains the ability to house that information differently, not just about the retention for a period of time, but the retention long term so that we can recall it as we have need of it.
There was a term used about, they called it a memory anchor. And I think that that was really a nice word picture for us, because what we're looking for isn't something that the child can just know long enough to get the score we want them to get on a test. They're going to grow up. They're going to be adults. They're going to live life. They're going to use math in enormous ways in their lives that they can't even predict, even if they don't go into any kind of a field that uses higher level, math. They're going to be using math everywhere in their lives, no matter what they're doing. We want them to be able to do this with confidence and not be feel unequipped. We want them to be equipped, not just with the knowledge of how to solve a problem on a piece of paper and pass a test, but how to use math in their lives and be successful adults.
So Lisa, can you now give us, because this is so omnipresent in our minds as we work with Matthew C on a daily basis, can you take a step back and explain to our audience and those who may watch this webinar at a later point in time the elements and how they fit together and why all of the pieces of the fit together of Build Right Say are so essential?
So if anybody has used Matthew C previously, you will be familiar with the term the build, write, say method. And that's what Steve Demi calls what is being done in Matthew C. And to be honest, it's being done as in more ways than you can imagine. I remember when I was using the gamma level for the first time, and the gamma level focuses on multiplication, and it blew my mind because he had the students building rectangles. I'm going to pull up, these are brand new. These are our new early learning blocks, and they're big. So they're good for little hands. If you've got little ones and you want to start teaching some early math, very low level math concepts. But the idea that you could take a number, in this case, I've got a 2 block, they're orange, and I'm putting 2 of them together and making a rectangle. Now, of course, in this particular situation, it's a square, because a rectangle is a certain kind of square. But he said, if you are talking about multiplication, you are talking about fast adding of the same numbers. So I've got a 2, but I've got 2 2s. If I had a 3, it would be 3 3s. If I had a 4, it would be 4 4s, and so forth. Or it can be any number. But what we're looking at here, like if I had 2 3s, I've got there. So I've got 2 3s, and I can skip count by 3, but I'm going to need to learn my multiplication facts. And the way that he does it is he has them build these rectangles and identify the dimensions, the over and the up. And those 2 dimensions are the same things as the 2 factors in a multiplication problem. And you've got a rectangle that you're finding the area. There are 6 square units. You can see square units. I remember going, oh my gosh, finding the area of a rectangle is the same thing as a multiplication problem. The ability to see this, to put this into a concrete application. You have a carpet in your house. How big is it? What's the area of that carpet? You can go and measure the 2 dimensions and multiply them, and you now know the area of that carpet or the wall standing next to you. The application for these things is practical and it's concrete. And so that's the way this is used. Now, when the blocks are one piece of the build, write, say method. And so we want them to build these rectangles physically, but don't stop there. We also want them to write this equation. And so it's going to be 3 times 2 equals 6. And they're going to speak it out loud. They've engaged tactile, visual, auditory, verbal, and writing. That's 5 ways to engage with that one problem. I remember Steve saying if he could have made them have a smell, he would, because that's an even more powerful sense. But what's happening now is your brain is getting bombarded with the same piece of information through 5 different sensory channels. And it's connecting those things in the brain. There's links happening, and those links tell the brain, oh, this is important. I need to move this into long-term memory. And then the more you do this, the more you are anchoring that in the memory.
Often we'll have parents who say, "Well, I understand the build, the right, but I'm missing the say." And frequently we have parents who'll miss the say with a young man
Yes.
because boys don't like to say things out loud. Don't make them do that. But that really is where, in the words of our colleague Sue Wachter, that's how the brain imprints the information into the right portion for later retrieval. That
Correct.
verbalization is enormous,
That's
and
correct. I remember a mom contacting me and they were using AIM to help her daughter, who was probably about 12 or 13, memorize her addition and subtraction facts and gain that automatic recall. And she was fine with the build and the write, but felt very silly saying it out loud. And so her mom said, "Any suggestions?" And I said, "Let her know that this is not about just doing something and feeling silly about it. This is for your brain." And that's all she did. She went back to her daughter and said, "This is for your brain." And her daughter went, "Okay." And then started doing it. And my goodness, what a difference it made. I just couldn't believe it. It was all I had to say to her. I didn't know what else to give her, but it worked. So so that's what we need to recognize. This is not about putting your children through embarrassing steps. This is for the brain because this is how our brains retain information best. And build better understanding as well. We're going after two things there, not just to be able to remember it, but also to really understand what they're doing so that they can take this math into life applications.
Lisa, you talk often about the fact that mathematics instruction is a bottoms up process. Can you explain that in a little bit more depth for our guests today?
And we've talked about this many times in other webinars, but unlike other subjects, math is naturally sequential. It builds concepts on itself cumulatively. You can teach history and geography and English and lots of other subjects in any order you want. But when you don't teach math in alignment with its natural sequence, gaps are created. And so it's sort of like you're constructing a building and you've left a crack in the foundation, or there's a gap in the first or second or third floor, and you keep building and building and building. You're adding weight to an insecure structure, and eventually it shows itself and comes, usually around algebra 1, comes crashing down. And we don't want that to happen to children because it is exasperating when you have to do a math problem or you're learning a new math concept and you don't have the skills, the prerequisite skills to be able to understand that new thing. There's missing information or missing tools. You can even think of it that way. And so what we want to make sure is that they're getting the appropriate tools all along the way. So when you look at Matthew C's sequence, it does not follow the typical sequence of a grade-based course where you might be teaching, oh my goodness, hundreds of different concepts in a single school year. And Matthew C does not work that way. Each lesson generally is one concept, and the mastery approach that Matthew C uses allows for the student to take however much time they need to master it and to be able to teach it back to you before you move to the next lesson so that those gaps are prevented. We want them to be layering. I know educationally they call this scaffolding, I believe. Um, but they're layering concepts one upon another so that they always feel equipped and confident to take on each new challenge.
And Lisa, this is often why you see families who raise their hands saying that math is not working for them about the time they have kids that hit the division level. Can you give us a brief explanation of what that really means?
Yeah, we see this a lot. When kids hit long division, they're having to not only deal with a multi-step problem, but they are employing all of the stuff they've previously learned. They need to be able to add and subtract. They need to be able to multiply and divide. They have to follow all of these multiple step procedures. They need to be able to put rounding and estimation to use. There's all of this going on. If there are any of those elements missing, what happens is every time they're faced with a problem in division, they're looking at this thing and they have to stop. And now they have to figure out, I don't know what this is. For instance, if they don't have their memories, their multiplication facts committed to long-term memory, they don't have that automatic recall. They have to stop what they're doing and skip count or sing a song or employ some kind of around the mountain strategy to get to their answer. By the time they've gotten their answer to the multiplication fact, they've already spent a good deal of brain battery. Now they come back to the problem and they've completely lost their place. where was I? What did I do last? What do I do next? And they almost have to start all over again. And then the next digit, they're faced with the same dilemma. The head comes off the page, the eyes go to the ceiling, and they're digging around to get that fact. And then they have to do subtraction facts, and they have to do the same thing with the subtraction facts. So much interruption, focus interruption, interruption of the procedure, all of it is they've lost it. So what we want to make sure is those math facts are mastered before you get to long division. Before you do subtraction, have the kids learn their addition facts. Before they're doing multiplication, make sure they can do addition and subtraction. And before they get to division, make sure that they know their multiplication facts like they know their name. And if they don't, call us and we will show you the strategies on how to make that happen. And when that happens, now they've got all the pieces in place.
I'm going to be the parent who calls and says, "Well, but Lisa, my son understands how to multiply 6 times 7. So how is that he understands how to do it. He's just not very quick at it."
What I say is ask him how he's getting his answer. And more often than not, they're either skip counting or they're singing a song or reciting a story or however they learned their facts. Sometimes they're using touch points, tally marks. I've seen all kinds of things when I send out assessments and I get the assessment back and there's all kinds of things going on the outsides of the pages. Tells me this child has not got that automatic recall of the facts. It's not a memorized fact. And so I know immediately they're being interrupted while they're trying to work. And that interruption means their brain is not free to focus on and remember the new material they're learning. So we want to make sure that all of those prerequisite skills are in order. And it means that they've got the tools they need when they have to do the next thing. And that's why Matthew C's sequence is so different. We're not just pulling a whole bunch of stuff in every year that they have to learn because someone decided that a third grader needs to know all of this. If they haven't got those prerequisite skills, they're not going to have what they say the third grader needs anyway. So let's not do that to them. Let's make sure they're learning their math skills in the same order that math naturally occurs.
Now, Lisa, when you and I actually participated in the preparation of a different recording in the last week or so, and you said that both alpha and gamma have a narrower focus. And I want you to elaborate on that a little bit, why that focus is narrow and what that does for a student long term. Because from the bleachers, you'll hear parents say, "Oh, you mean you're gonna make us spend a whole year learning addition and subtraction, or you're gonna make us spend a whole year working on just multiplication?"
Every Matthew C level has a major focus, and then it also teaches associated skills. There are fewer associated skills taught in alpha and gamma levels because in those two levels, we're also asking students to gain that automatic recall of the facts, memorize those facts, but not a rote memorization. And I know some people bristle at the thought of memorizing because they feel like it's rote memorization. Well, rote memorization is just going to go out the door soon enough anyway. We want to make sure that it's imprinted into long-term memory. And there are strategies to do that. And the Build Right Say is probably the most effective way that I've ever seen to do that because they are engaging so many senses. And I know that parents will often feel impatient. Why aren't they learning all of these other things when our neighbor's child who's in first or third grade is learning all of these other things? Well, here's the problem. Those kids are probably counting on their fingers because there isn't enough time to give that child the chance to gain that long-term memory of those facts because they're on to the next thing and the next thing and the next thing. And Matthew C's alpha and gamma levels give them more time. There's more free space so that they can not only learn the why behind everything, but they're also having time to memorize the facts. In alpha, We are using the blocks as you demonstrated just a few minutes ago, and we're building lines to show equal values. But we're employing that build, write, say method. And in Gamma, we're building rectangles in the same way and identifying the dimensions, but using the build, write, say method. And building bridges between concepts at the same time. One of the things that I think is so marvelous is that we are able to employ very low level but concrete um, concepts of algebra in very young levels. So you just demonstrated if we have a 3 and a 2 and we want to build, write, and say what 3 plus 2 is. So we've got a 2 and a 3. Oops, I've got this one backwards. There we go. And then they're going to find the 5 block and recognize that the 5 block has the same value as 2 and 3 when they're added together. They even make a groovy little equal sign. Well, at some point, we're going to knock out one of those addends, and it's going to become what number plus 3 equals 5. That's algebra. It's a very low level algebra. And so by the time they get to algebra, they're not going to get thrown by having alphabet letters in their math problems. But what this also does then is it builds a bridge between addition and subtraction so that they know now that when they have 5 minus 3, what's left over is 2. So we are building bridges and making connections, relationship connections between the different operations in math. When they start learning multiplication, we start by skip counting so that they are building a bridge between addition and multiplication. But we don't want to leave them on the bridge. We want to bring them over to fact mastery. And then we do the same thing with in Gamma, where we are learning how to solve for an unknown factor. And that's going to lay the groundwork for division to follow. So again, we're making connections, relationships between the operations, and we're doing it with concrete objects. I want to also say that although it's not said so in the build, write, say method, it is employed in our materials because the instruction manual also includes pictures of these blocks. And I will say, it's also, we'll talk about this as well, but it also means the fraction overlays when we get to epsilon, because we don't use the blocks as often in epsilon. We use those fraction overlays. But again, we are building we're building out the problem so that they can see it. It makes sense to them. And then the drawings of those very same objects are in the instruction manual. So if you haven't been using your instruction manual, use it. It's going to add another layer, even if you're just showing the drawings to your child. They're working with the physical objects, but then let them also see them in flat two-dimensional drawings before you introduce the written problems.
It's the top of the hour, and we have just a couple of minutes left. So, what would be your closing thoughts for our conversation
Yeah,
today?
I mean, first of all, if you want to do some research on the CRA model, go for it. It's really, really interesting. But take a look at the way that Matthew C. stands apart, and the way that it teaches math has been effective for children for 35 plus years now. And I have 4 kids that went through it, and they don't all learn the same way. I wasn't dealing with, some of the learning challenges that many parents are, but I have to tell you, I've got parents that are calling us, and they have children who have been diagnosed with dyslexia or dyscalculia, um, ADHD, working memory problems, Down syndrome, autism. We have children with various learning challenges, and they are finding success in learning with Matthew C. because of the multisensory engagement, the mastery approach, and the unique sequence that Matthew C. uses. Like I said, I just think it's a trifecta. I think it's a formula for success. If you have any questions, please give us a call. We're here. Amanda Capps and I are placement specialists. The rest of our customer service team are fabulous people who love, love, love to talk to homeschooling families and teachers and would love to help and answer any of your questions.
Absolutely. Lisa, I want to thank you for taking the time for bringing my attention to the fact that we needed to have a more in-depth conversation about this. I think it was a really important conversation. And of course, I so appreciate the depth and breadth of preparation. If y'all knew the depth and breadth and preparation that Lisa has brought to this experience, you would be humbled and proud for Lisa for all that she prepared in this process, because she really did do a great deal of digging into the why behind the process so that you would be able to understand it more thoroughly. I want to thank you all for joining us today, for trusting us to come into your living room. It's, as always, my very great pleasure to host the show, and you can see why I love doing what I do. I have tremendous colleagues that I get to work alongside, and we get to help families like you. So thank you all today for joining us, and we'll look forward to your coming alongside us again in the near future. Take care, everyone.
Thanks again for joining us. We're glad to be a part of your educational community. You can help us grow our community even more by rating, reviewing, and subscribing to the show wherever you may be hearing this. Don't forget that you can access the show notes and watch a recording at demilearning.com/show or on our YouTube channel. We'll see you again next time. Until then, keep building strong foundations for lifelong learning.